Hello everyone, I am Dr. Regina Anandi, Assistant Professor, Department of Artificial Intelligence and Data Science. Today we will be discussing the document data model, which is one of the core concepts of MongoDB database management system. So unlike relational databases that stores data in tables, MongoDB stores data in documents. So this document-oriented approach provides flexibility, allows us to represent complex real-world data naturally, and makes application development easier. So during this session, we will understand what the document data model is, explore its structure and features, learn about embedded data, and examine how it is used in the real-world applications. So before we learning the document data model, let's quickly recap some MongoDB basics. First, NoSQL databases are designed to handle structured, semi-structured and unstructured data with a flexible schema. Second, MongoDB stores information inside the collections which are similar to tables in the relational databases. Finally, data is stored as a JSON-like documents, specifically BSONs documents instead of rows and columns. So these concepts form the foundation of the document data model that we will study today. So let's understand why the document data model is needed. So modern applications manage complex information that often changes over time. Traditional relational databases required predefined schemas, making structural changes difficult as applications evolve. So applications also need to be represent nested or related information efficiently without requiring multiple joins. So document data model solves these problems by allowing developers to store related information together within a single document, making data retrieval simpler and faster. Now let's define the document data model. So the document is a basic unit of data storage in MongoDB. Each document consists of field value pairs where fields represents attributes and values store the corresponding information. Documents are stored inside the collections and are represented in BSON format, which is MongoDB's binary versions of JSON. One major advantage is that documents within the same collections do not need to have identical structures. Different documents may contain different fields depending on the application requirements. So the flexibility makes MongoDB highly suitable for modern application development. So this particular slide shows us an example of MongoDB documents. Each document contains fields such as ID, name, email and age. The ID field uniquely identifies every document within the collection. Unlike relational databases where each row must follow the same table structure, MongoDB allows additional fields to be added whenever needed without modifying the existing collection schema. So this flexibility enables developers to adapt their data model as application requirements evolve. The document data model provides several important features. The first feature is flexible schema, which is developers can easily add, modify or remove fields without restructuring the entire databases. The second feature is nested documents, where related information can be stored inside another document instead of creating the multiple tables. The third feature is array support, allowing multiple values to be stored within a single field. Together, these features simplify data management while improving development speed and application flexibility. Here we see how multiple documents are organized inside the collections. Collection groups documents that represent similar entities such as users or products. Although the documents belong to the same collection, each document must have a different fields depending on the available information. For example, one user may include a phone number while the other user may not. So this flexibility distinguishes the MongoDB collections from the relational database tables. So one of the MongoDB's powerful features is embedded data. Instead of storing related information in separate tables, MongoDB allows us to embed related documents inside a parent document. For example, a customer document can directly include address information. This reduces the need for multiple database queries because the related data can be retrieved in a single operation. However, these embedded documents are more suitable when the related data is closely associated and does not even exist independently. Let's summarize the main advantages of the document data model. First, it provides high flexibility, allowing the database structure to evolve with application requirements. Second, storing related information together improves query performance since fewer database operations are required. Third, the document data model naturally represents a real world object, making application development simpler and easier to understand. Overall, the document model improves developer productivity while supporting the scalable application. Now let's see the real-time example. So let's how the data model, document data model is used in the real-world applications like Uber. When a customer books a ride, information such as rider details, driver details, pickup location, destination and trip status can all be represented as a document. Some related information such as pickup and destination addresses can be embedded with the ride document. Another important independent entry such as driver profiles or customer accounts can be stored in the separate collections and referenced when needed. This approach enables Uber to efficiently process millions of ride requests while maintaining a flexibility and a high performance. Now quickly we'll summarize today's lesson. We learned that MongoDB stores information as document instead of tables. We discussed the structure of documents, collections and field value pairs. We explored important features such as flexible schema, nested documents, arrays and embedded data. Finally, we saw how the document data model is applied in real-world applications like Uber. The key takeaway here is that the document data model provides flexibility, better performance and a more natural way to represent the real-world data. So let's quickly check our understanding with a short quiz. Try to answer these questions based on today's discussion. Think about the concept we covered, including the document structure, collections, embedded. That brings us to the end of today's presentation. Thank you.